And yes, and but he thought about like framing it also as like a classification problem of
Really?
like if at a certain point in time the model would say like it's going to go 5% up or 5% down or a number of just some range of percentages, and
Right,
that way
right.
it would be a classification rather than a regression problem, and maybe that could be
More
something we could.
tractable.
That
I don't know if that makes it easier for training.
Uh, I don't know either. I would think so, but it's purely based on intuition.
Yeah, I think from like classification problems are supposed to be more stable for whatever reason, you know, whatever loss function they use. And so some people do this sometimes, like, and there's other like ways you can do it. You can take what is, you know, predicting a numeric value, like a number, like 5%, and you can bin it into different levels. So you could have, you know, bins of every 0.5%, and so that sometimes helps the training process become more stable. And so yeah, that'd be really interesting to try out. And even like another one, if you wanted to have really big bins, you could just have like positive or negative. Is it going to go up or down or something like that? You know,
yeah.
so there's lots of really cool ways you could frame it.
Yeah, there is a protocol, it's called Into the Block, that they have this machine learning classification algorithm that they try to predict for the most common tokens if they're going up or down. And it's kind of cool to see. You know, I'm not sure how accurate they are, but I thought the project was pretty interesting.
Super cool. Yeah.
But like, how would we would have to create the classifications, right? Like the ranges of the rates. Do you guys want to try that out? Maybe every 1% or 2%.
Yeah, for sure.
Yeah, I guess one thing that I was wondering about was if we turned it into a classification problem, would we have to have like time varying predictions? Like it's gonna go up 5%, but in how long of a time frame?
Oh yeah, that's correct.
Like because it's definitely not gonna be well, not definitely, but I presume it's not gonna be that deterministic that every two blocks, let's say, it's gonna change by the same amount. And I don't know if that basically makes it more complicated than what we're doing right now.
Yeah, I'm having a little bit of trouble to understand how to apply a classification problem to a time series problem.
Well, I'm guessing that time is discrete, is quantized in some way, right? When you do that, you're splitting time in bins, if I understand this correctly. And then you're gonna have a classification answer for every one of those bins given the historical data that you fed to the algorithm so far, right? Well, actually, I mean, you're gonna train a model and then you're probably gonna stop unless you do some other sort of online training as you go. I mean, you're gonna train it and then you're gonna stop, but you're gonna answer those. Is it gonna go up or down question based on some bin and then some historical data that you give to the algorithm, right? Which is not part of the training, but it's part of the input. That would be my guess.
So like based on the classifications, let's say like that of T0, you would be able to say how it would look like at T1.
Yeah, I mean, I don't know what size of window it would have. I'm guessing that probably you're gonna give a window that is larger than just one bin. Maybe you're gonna give it 4 or 5 bins. Maybe if you give it too many bins, then it starts getting the answer wrong, because then you're gonna have exogenous things going on and things that become harder and harder to identify a structure in it. That would be my guess. But I'm guessing that the parameter. I mean, it's probably a parameter of whatever it is that you're trying to do. But I'm guessing that you're going to have this historical set of bins. Maybe I don't even know if it makes sense to talk about bins here, but you're going to have some length of data here that you're going to give as an input, and then this is going to predict what happens here. That would be my guess for the. And then answering to the how far into the future you're going to predict. Well, it's a bin. So if your bin is large, then I'm guessing you're gonna give a kind of an inaccurate answer, because yeah, it's gonna go 5% over that bin. Not sure when. Maybe your bin is like, if your bin is a month long, then the answer is I don't know if it's a good answer actually, because I say yeah, it's gonna go 5% over the next month. I don't know how useful that is, but I'm guessing those things are gonna depend on basically how you structure your training, right?
Yeah. It depends as well, like how you set up the problem, whether it's going to compound. So like, you know, for the most simple model, maybe you're just predicting one time step into the future. And then at that next time step, you predict another time step into the future. And so the error is kind of compounding as you go out. Whereas if you're, you know, you could set up your model so that you're predicting multiple time steps into the future, that would be a slightly different setup. But in terms of the, like, what does it mean as a classification problem? Another way of thinking about it is like, you can think of it in terms of probabilities. So if we're trying to identify what type of animal we're looking at, the value will be between 0 and 1. And so, you know, the answer to the classification is basically the category that has the highest value between 0 and 1. So it could be, you know, 0.9, which means that it doesn't actually mean this in terms of probability. We have to be careful with being strict. It doesn't mean there's a 90% chance of a dog or something, because machine learning doesn't map well to probabilities and stuff. But yeah, you can kind of think of it like that. And so if you think of predicting one time step into the future and trying to think which bin of borrowing costs are we in, let's say it's between 0 and 5, and we've discretized it into 10 different bins, you can think of each of the classification for whether it's in each bin is kind of like a probability of whether it's in that range or not. And so maybe the bin between 4.5 and 5 is like 30%. And then maybe the bin between, you know, another range is like 10%. And so that's kind of how you can think about it in a classification problem, I guess.
Yeah. That would be a multi-class.
Go on, Julian, sorry.
No, I'm thinking in this case, you would be like taking several classes and guessing the likelihood of each one of them in this using these scores, right? If I understand what Richard said.
You use multiple methods and then check. Yeah, I mean, like, this is kind of called like an ensemble. So usually, you know, in terms of the wisdom of crowds, there's also the wisdom of like many machine learning models. So like the best answer is usually an ensemble of lots of different approaches. And so it's also the most computationally expensive though. So a lot of times what happens in Kaggle competitions is that an ensemble of, you know, 10 different models wins, but that's not actually feasible in real world products, I suppose. And so ideally we would just use a single model and find the one that works best, but it would also be interesting to ensemble a few and see if that improved the results.
So Richard, like by your approach, you would be kind of building a probabilistic distribution of the inputs, and then based on the last n bins, as Juliano said, what's the most likely outcome? That's pretty much it. But like this probabilistic distribution is based on what? Like that's what I'm having problem to figure it out.
You need to like, so you would change the historical data into bins. And so, you know, like, so when we're predicting, like you said, it's kind of like a probability distribution, right? So maybe the probability is highest around a certain bin, and then the bin either side of that is slightly lower and slightly lower, so that it looks like a normal distribution or something like this.
Yeah.
And so like how we would train that is we would go back through all historical data, and the probability distribution would basically look like all zeros in the bins where it wasn't in that range, and then a 1 in the range that it was. And so that's kind of like your probability distribution that you're training it on. Or maybe you could do it like a bit differently. Maybe you wouldn't have 0 and then 1 and then 0. You could actually make it look like a normal distribution more and stuff like that. And so
now I got it. Yeah, that's very, very interesting.
Yeah.
Also, no, I was just gonna say that another thing that Archie mentioned was that we could possibly add like sentiment analysis to the training data, like something like mentions of like DAI borrow rate or DAI borrowing on Twitter, like based on the number of mentions or something like that. and that could theoretically be like added to the tabular data so that it's like one giant DeFi data set. Again, that might probably be like a side project, I suppose.
This would be
Yeah.
super cool.
Yeah,
And
that's
that
very
ties in-
interesting. I feel like looking at social media mentions or talks in like the effect of this in the actual market, it's a whole project by itself. It doesn't only affect the borrowing rates, but I guess it could affect prices and everything else.
I think that was what the I can't remember his name from Munchies Index was trying to do.
Stone Rice AI.
Yeah.
Yeah, that would be super cool. Yeah.
What is the project? Just so I take a look at it.
Yeah, if you go on our discourse, it was called the Munchies Index. So he has basically collected, yeah, it's a good name, all right. So he has collected a big data set of social media posts, I think like on Reddit and places like this about cannabis in the cannabis industry in particular, and with the intention of trading cannabis stocks. And so I don't think he's done a huge amount of data science or machine learning. I think he's using quite simple metrics, things like word counts and stuff across different social media posts. But I know a lot of people do this with the regular stock market, train language models on like all of the tweets or all of the social media posts and predict like a sentiment score and things like that. And so it's quite a popular approach in like the stock trading world, I suppose. And I think he's like the first person to apply it to, the cannabis industry in particular, which is cool. And like, I'd be surprised if someone has applied it to, the DeFi world. Yes, all of the sentiment analysis stuff. So it'd be really interesting to explore, but it's also a massive project at the same time. I wonder, because I actually didn't get a chance to catch up on last week's video yet, but I still plan to. So I wonder, in terms of the model, would someone be able to explain to me how far we got in terms of, is it, I saw there was talk about using multiple parameters and stuff like that. From what I saw anyway, it seems like we're getting more reasonable results with the model now, in that, we can't predict 4 months into the future with like 90% accuracy and stuff like that. So that always gives confidence. But yeah, would someone be able to give an overview of like, are we still using a single parameter, multiple parameters, and where are we at?
Yeah, so that actually reminds me of another thing that Archie mentioned, which is like based on how we want to then deploy the model, like how far into the future do we actually want to predict? Like, I think it would be good to decide that so that we know like where we're aiming. The tabular model, I think he tried it for 3 time steps into the future, so 1.5 hours, and then 10, and then 20. And I think let me quickly check. I think that for 1.5 hours it was like 85% accuracy, and then for the 10 and 20 it dropped quite drastically, and it was I think it was less than 50% for the 20 and like 65 for the 10, something like that. And then we also have an LSTM model, which I think had similar results. And then Archie is right now working on the Saint model, which is also, I think, a transform. Yeah, it is a transformer, and it should probably be like a slightly less overkill version of the temporal fusion transformer, because that one is like I think it probably has too many parameters for the data set that we're using. Like if we had the data set that Christian said he'd collect for the like block by block. I don't know if he posted something on Discord. I'm not sure if it was the data set.
I think it was another data set that he collected for another user that asked.
Okay. Yeah, but I think the block by block should be like, that should be so much data that we're probably not even gonna need that much. But Yeah. And then for the for some reason that the temporal fusion transformer from PyTorch forecasting is not doing that well. But it might also be that we're not setting it up correctly. So I'm trying to train it with like all of the features as classified as unknown time varying values, which is just a parameter that it takes when you're initializing the data set. But it's taking so long to train, even on Google Colab. I don't know if I set up Google Colab incorrectly, but it took like an hour just to find the best learning rate, which I thought was kind of weird. And now it's training the model, but yeah, so far I'm not sure how it's performing.
Yeah, about the session itself we had yesterday, not yesterday, last week. I think we're more engaged on trying to expand the data set we had. So we spent a good time on doing analytics and trying to make the right queries to get the data, but we weren't able to do so. So we're still working with the same data we previously had. And the models, I think the tabular one is still the leading one for results. I don't think we took a better look at the hacking session yet. I took it like on my personal time, but I guess we could take a better look now. Do you know why Archie isn't able to come to the meetings, Jakub? Is the timing bad for him, or?
Yeah, I think he's in Asia, so it's
yeah.
like, I don't know, middle of the night.
Yeah, that sucks.
You guys probably can't go much earlier. Is there some space on that side of things?
I could probably go earlier.
Yeah, I can go as well.
Yeah, for us wouldn't be a problem as well.
I think it would make sense to see if we can accommodate Archie, just because he's, you know, doing a lot of the modeling and stuff now. So yeah, maybe we can discuss in the channel and just suggest some times and see what works for people.
One thing that I thought was, since the tabular model is performing quite well, maybe we could just like expand that rather than try to train these giant models from scratch. So maybe either like add, I don't know what the best practice is here, Richard, whether we should have the trained tabular model and then add new layers to the pre-trained model. That would be perhaps, well, the thing with the tabular model is that we have to, like, if we want to train multiple windows, we have to prepare the data beforehand, whereas with the transformer, I think there's like the multi-head attention, where it can automatically look at different rows. I don't know if that really makes a difference, whether we have to concatenate the rows, or whether the transformer does it for us. Although I'm not sure how it works with the attention layer, whether when the transformer is looking at multiple rows, whether it assigns different values to each row. Like, I guess that for, like, if we're predicting an hour into the future, then the borrowing rate now should have a higher value than the borrowing rate an hour ago. And for the tabular model, we're just passing it like three rows at a time, but they're all the same. They all have the same weight. I don't, has anyone come across like the transformer implementation and whether it assigns like different weights to pass data? I guess we can do that manually as well. Like, if we can concatenate different rows, we could have like some kind of value distribution that we just multiply everything by.
I'd need to jump into the type of transformer model to understand what you're saying, but I agree with what you said initially, which is, you know, if the first model we were playing around with works quite well, I think it would be really useful to study that. So, you know, just pick a model and then maybe change the different input variables and things like that, like we discussed before. So I guess, I'm not sure, did you say is it a single parameter that we're passing in at the moment, just a single time series, or have we moved on to the multi-variable, like multiple time series as input?
I think that we have both now.
I think for the tabular one, we're just using the DAI borrowing rate. Did Archie explain that? Because I think when I looked at it, was only the DAI borrowing rate. I'm not even sure like if it's possible to fit multiple time series into the model.
Yeah, he sent me another notebook. I'm not sure whether he posted it to the repo yet or not, but it is like multiple for multiple tokens, I think.
Yeah, it would be interesting to start to analyze the results in more detail, I suppose. I think that would be really interesting. And, you know, from the data science side, but also from the business use case side. So like those values that you said, what was the accuracy at like an hour and a half into future, Jakob? Was 80, 90%?
Yeah, I think it was, I need to just make sure that I'm saying the correct thing. Yeah, here's one that's 90%. I think that's the one that's 3 time steps into the future. Yeah, so the 3 time steps into the future, I got 90%. And then for the target window 20, it's just 42%. And when we pass 20 rows from the past and then predicted 20 in the future. So that all of these were with 3 rows concatenated together. So like t minus 2, t minus 1, and t. And for the one with up to t minus 20, that did even worse. That was just 16%. Yeah, and then the LSTM. Oh, the LSTM is actually pretty good. That was 79% for 5 time steps into the future. And no, wait.
Pretty good anyway, I guess.
Yeah, the LSTM is doing quite well as well.
I wonder, Greg, from the business.
Yeah, actually, I had a thought here. In fact, you know, multiple uses of this type of thing. I think just as a soundbite, it could be interesting to like package what the statement is. Like if we could say, oh, we're able to predict 2.5 hours into the future at 72% accuracy, and just I would maybe add, like, if we could use an example what a 72% accuracy would mean to a non-data scientist. Like, for example, if the rate currently is 10%, then I don't know what that would actually look like, but this, I think, is a very powerful message to people of like the potential of what we're working on. So like now we're able to see 2.5 hours in the future, but you know, we believe that shortly that could be a day or a week or something like this. And then you can start to see the applications unlocking. So I don't know if it's maybe premature to think of what that might sound like, or maybe I could just kind of look at the raw data and try to take a stab myself.
Yeah, even though the temporal fusion transformer is not having great results, one very cool piece they have in their documentation is this visual, this data visualization of their prediction, where they like show the actual time series and then the points that they have predicted. Then you can see like how close it actually is. So we could do that, you know, even if it's only 5 points into the future. I think it's a great showcase of what we're doing here already, and that would be cool.
Yeah, that'd be really cool to have a look at the results like collectively during these sessions. And I think, yeah, Greg, what you said makes perfect sense. Like, you know, 80% doesn't really give much of like it's an average number, right? So it would be interesting to break that down into what it really means. And like one of the things I was thinking, for example, is because it sounds like really good accuracy. It's probably like really easy to predict if the borrowing rate is increasing time step by time step. It's probably quite easy to guess that, you know, it's going to increase the next time step. But it would be interesting to see what happens when there's like a sharp change. So it goes from an increasing trend to a decreasing trend and stuff like that. Does it get that wrong every time?
Yeah, it has.
If it does,
if I understand correctly what you're saying, Richard, we have to see if it's actually able to predict the important stuff, right? Not the obvious stuff in some sense. Yeah, there's a trend. Probably it's going to stay the same. So if you guess that it's going to stay the same, you're going to get it right like, most of the time. Yeah.
We could even come up with a baseline, like for example, a very simple predictor that just says, you know, take how much it increased in the last time step and predict that it's going to increase by that much again in the next time step. That would be a really interesting baseline to compare against.
Yeah, exactly. That was my thought as well. Yeah.
Because predicting that using a very simple algorithm like that, you might get like 80% accuracy, and that 80% is your baseline, and that actually machine learning is just doing that.
Right.
You know, it's just learning this very simple thing. So yeah, just really like digging into the results for a single model and seeing when it's right, when it's wrong, all this sort of stuff could be really useful. And then the other thing is, you know, like I guess I'd love to understand more. If we reach a certain level of accuracy, what does that mean for, you know, how much money can you save by rebalancing the tokens you're staking based on, you know, an hour and a half prediction into the future? And
yeah, that's great. Yeah,
that would be really cool, because that's what like these platforms that I used to play around with used to do. You could like simulate, you could create a trading strategy, or in this case, like, you know, a staking strategy, and you could, you know, simulate that on previous data and see how much, you know, this extra hour and a half prediction into the future, how much you could actually save or make and things like that. So it'd be really interesting to come up with this kind of like a simulator that would allow us to simulate certain staking strategies based on, you know, predictions that we're getting from this model, and see how much that can save you and stuff. That'd be really cool.
Yeah, that's awesome. Yeah, awesome. One thought, Jakob, I think that it would be pretty awesome to keep expanding the tabular model. And now I'm happy to join you and Archie on your hacking sessions. And I had one more thing to say, but I just forgot.
Yeah, I think hopefully Archie will be able to join us next time, like if we find a time that works for everyone.
Yeah.
I think, yeah, I feel like it's probably something we're not doing correctly with the PyTorch forecasting one, because it would be really cool to get that working. Plus, just because as you said, they have the visualizing methods. Yeah,
but we could made our own visualization methods as well. I don't think it's that hard to do. And I just remember what I was going to say is that working with the tabular model gives us a little bit more room to test, because as you say, every training for the PyTorch one is taking, I don't know, like 5 or 6 hours. So like we would group, you know, we would set up some parameters, and then only 6 hours later, we would actually have something to talk about. So I think for the tabular one, we have more room to just try different stuff out and see what's popping. So I think it's more productive, at least for now.
Also, so in terms of the like applications, like even if we have like a simulator that can show that predicting 2 hours into the future would give you this much gains, is it, do you think this like 2 hours into the future is enough time for it to be like a solution for humans essentially? Like I feel like that's something a trading bot would use, because a trading bot can be deployed all the time and actually change its strategy every 2 hours. But if it's something that that people would want to use, I feel like that it should probably be a longer time frame.
I agree with that. I mean, I think it does unlock some applications, but at least kind of with our narrow lens of what we're doing at Window, we're not arbitraging, we're not building bots, we're doing longer term things. So I think it just kind of, maybe it would be helpful if we sat down and defined what a good window would be, like, and we could do that. And we could also think of what applications, it's kind of like a solution leading to a problem, maybe a bit, but like what kind of applications does this unlock that we didn't consider, if we do have maybe a shorter window but a higher accuracy. But the former seems like a more productive exercise.
Yeah, I think Richard's idea of actually like running a calculation to see how much valuable that is, it is useful, because if you just took the the data set we have and say we're going to be rebalancing our stablecoin borrowings every like 2 hours or so, and see if you could like move to the lower rate to see how much that would save in a year. So maybe the number that we will find is actually higher than we're thinking. And to expand though that time window, the time step we're predicting to the future, I think it's also good to remember we are only using like one compound data set. So I feel like we still haven't brought up like big guns to solve the problem, because if we had like compound data and then Aave data and maker data and then I don't know, like gas data and blockchain data, maybe we could really expand that into, I don't know, like 3 hours, 4 hours, and then just going forward. Like with the same model, we could have better results by just having more inputs.
Yeah, for sure. And on the, I think just like you've walked us through all of the stuff with, DeFi data and the DeFi, how the borrowing rate is predicted and stuff, it would be really useful for me at least to understand, let's say you had perfect information, what do you need to do to save money, like a step-by-step almost, if we know that this borrowing rate is going to increase, is it that simple? If one borrowing rate is going to increase and one is going to decrease, you just swap into the one where it's going to decrease, I guess.
Yeah, I think you're talking about stablecoin. Then yeah, like between USDC, USDT, and DAI, I think which one is the cheapest. Okay. Doesn't really matter.
So whichever is the lowest borrowing rate, that's the one that we want to be in at that point in time.
Yeah, I think so.
And like, does that apply for when you're already borrowing? So can you kind of like liquidate your loan and take it out with a different coin or something like that?
You could do things like that. Yeah, I could see applications of this. In fact, as I was thinking about the short-term problem, maybe this is a bit of a tangent, but if you are taking on a lot of leverage for whatever position, if we can predict not this kind of steady state differences, but like these kind of unexpected blips that could cause some sort of liquidation, that seems like a pretty big unlock. And that maybe it's not going to be an arbitrage, but it might be just kind of like a heads up. You might want to pull out of a position that you're in.
Yeah, because you have a lot of people that are working really on the limit. So, for example, they are depositing, I don't know, ETH and then borrowing dollars to buy more ETH. And then if the borrowing rate just goes up too much, he might be on risk of losing a lot of money.
Yeah, and sometimes kind of. I was just going to add really quickly. Unwinding positions, if there's kind of like a market turbulence, is also, it could take time and can be crazy expensive and slow as well. So like, I think just having an hour and a half heads up, if we could really do that, seems like an interesting window.
I was going to say, Christian added the Aave liquidation data set. So we can tie that in once we start dealing with the Aave data.
Nice. And like depending on which application you actually want to use it, that can frame the way that you set up the problem. Like, for example, if we just want to predict when a big change in direction is going to happen, maybe you set it up as a classification problem where it's like, what's the probability of a big liquidation between 0 and 1? And so that would be even different to the way that we set up the bins and stuff. And so I think, yeah, like now that we've gone through, we know how the borrowing rate is calculated and all this sort of stuff. It would be interesting maybe next week to go through some of the different applications. And I think you put together 3 on the grants proposal, I think, if I remember correctly, 3 different applications. And
yes,
I think there might even be more than that. And so
sure.
it might be useful to go through some of these and like what each of these applications would look like. What are the considerations for that? Like how long will we need to predict into the future potentially for this application to be realized, and different things like that I think would be really useful.
Yeah, I think Christian data set that Vintage mentioned is one that I think it just lists the liquidations that had in the previous year or so. I think we could take a look of the borrowing rate for telling us something about it. So for example, if there is a big liquidation volume in the month of April, I don't know, we could see what was happening with the borrowing rates before that and see if there is any indication that could happen.
Sounds great. Yeah. So yeah, I guess like we've got the models like running quite well, and now we're moving close to the applications. Like, what can we do with these models that we have, which is great, I think. And I wonder, just now that we have like around 10 minutes left, and now that so what we've been working on is trying to figure out how to fund the different squads that were successful in the grants and stuff. So we don't want to tell the squads how to govern themselves and distribute the funds and all that sort of stuff. That's up to everyone in this squad. So I don't know if we could like kick off the conversation, whether anyone here had any preferences about how we wanted to use the funds, like how do we want to distribute the rewards to contributors. Does anyone have any ideas for any of this sort of stuff?
I think there's like the people that are building the models, then you have like the analytics of the models, and then you have the vision. So I think there are definitely 3 components, 3 different responsibilities here.
Yeah, more broadly in general, like data science projects bring together lots of different stakeholders, and this squad in particular is one that has like I think pretty much all the different stakeholders that we need to make a project successful, which is really exciting. But there's also like how do you reward different types of contributors and different types of stakeholders and all that sort of stuff is a difficult question. I guess like a good way to start off is just everyone equal, and then like yeah, I don't know. I wonder if you have any ideas for how that would work.
I think at first it would be cool to have like just everyone equal, but then in the future we could start to set up these roles, as Vintage said. So we would have the people working more closely on getting the data, people more closely on building the models, and and stuff like that. And I think it makes it more feasible for people to join as well, because they can see like which roles they can fill, whatever they feel more comfortable doing, and yeah.
I wonder whether
Yeah.
we
Go ahead,
can
Jakob.
set up like I think we already have a Google Doc, but I don't know whether I don't think it's really used. Yeah, just it would be good to set up something where we can more effectively work asynchronously. So like, I mean, the Discord is like for coordination, but then in terms of tracking contributions, I guess like it would be good if we had a document where somebody would write, hey, I did this, and then maybe like in case of the Google Doc, comment and then ping everyone or something, if they want some feedback or something like that. And then we could probably set up Coordinape, where we would like I think Coordinape is where everyone gives like not rewards, but like appraisal based on the contributions, subjective contributions. But since there would be like this one single source of truth in a shared document, that would make that process a bit easier, because right now it is kind of informal. Like I think like Archie has been doing so much with the models, and it would be great if there was like more communication, because that's also how we move forward a bit quicker, I guess.
Yeah.
Richard, sorry, Greg, go on.
Yeah, I'll try to be quick. So for one, I actually, I think your solution, Jakob, is more elegant than what I had thought of. Basically, I had thought that beyond the roles, like I, for one, I don't think I deserve more than a penny, just because like you guys are doing the hard work, and it's clear that you're working kind of asynchronously and putting efforts into this. So like my dumb idea was to have some sort of multiplier or on effort and like time spent within the role. But Coordinape is probably even more elegant because it's kind of, it's subjective, but in a beautiful way. Like it's, you know, so that's a thought. The other thought I had was, you know, when we work on our projects internally, we would use some sort of Kanban board or you know, we use Asana. A lot of people use Trello, but you know, at least it has some sort of mechanism for asynchronous communication and tracking of kind of like good ideas sometimes as well. So I'm more than happy to create a like a guest only project in Asana, but I know Asana is a little bit kind of a bigger learning curve than maybe a Trello or something else. Maybe if everyone's already in Jira, that works as well. Yeah.
I think that's a really good idea. Yeah. I've tried to set up Kanban boards for previous projects, but I just don't have time to keep on top of them and keep them up to date, which I think is really important. But yeah, if everyone wanted to, in other words, I won't be able to do it, but if everyone else wants to keep up to date with all of the cards and stuff, I think that sounds like a great idea. And Trello or Asana or whatever people think would be great.
Yeah, I will be happy to do so, you know, to help out putting up the cards and also planning the meetings. I feel like having a combo board like that also helps us to keep this hacky session more efficient, because like if everyone already kind of knows what we're going to talk about, then we save up a little bit of time. So I think that's super helpful. Yeah, I was just wondering, Richard, if there is anything that the Algovera forum could also help us with that. You know, maybe we could have some organization in there, or maybe we just use the Compart as well. Whatever you guys think is best.
Yeah, we're planning to set up a Notion page for each squad where, you know, that can be like a wiki and all of the details of the project and stuff like that. So I don't know, it's like maybe that works for people. We could have a central page where we coordinate this sort of stuff, figure out what sort of things we need, like maybe a calendar, a Kanban board. We can like link to everything related to the project from one place. Is that sort of thing what you meant?
Exactly. Yeah.
Perfect. Yeah. We can do that for sure. Yeah, I think that'll be really good. And we also, like, we've set up Coordinape before and stuff, so we could definitely get a Coordinape circle going for the first time. I've actually never used it before, but as far as I know, it's, you know, everyone gets some tokens that they need to distribute to other people based on, you know, like how many tasks they think they've completed and stuff like that. So I don't know the full details, but like that seems like an interesting process. And I know how some other DAOs do it, like the token engineering DAO. They use the praise system, and so what happens there is that you type !praise and then a person and then a reason, and this all goes into like a database, and then they basically audit this database and they categorize, you know, this person was praised for a technical task, this person was praised for another type of task, this person was praised for another type of task, and so they assign like scores to each category of task, and then they see if it seems fair to everyone. So it seems quite like information processing heavy, I guess. And even I've seen some of their presentations recently. Apparently a third of the people in the token engineering DAO aren't happy. They don't think it fairly reflects what they've done, even after all of that work. So yeah, I think sometimes like the simpler solutions are the best. But yeah, there's lots of options.
sentiment analysis on the reasons for praise.
Machine learning models for predicting contributions.
But then it's unfortunately very like hackable. Everyone just puts maximum sentiment.
Once what do they say? Once a measure becomes a target, it ceases to become a measure, or something like this. A famous expression. But yeah, okay, cool. Yeah, we're still setting up all of those processes, I suppose, and so hopefully going to distribute the funds as soon as possible, like maybe in the next week. There's just lots of stuff to get working, like the DAO framework and all these sorts of things, and set up the Notion pages. But what we're hoping is, like, once we set up our squads, it will help to facilitate collaboration between these projects. Like we've, I guess it's been a bit ad hoc at times, but as we start to, implement more structure and practices, whether it's things like the Kanban boards or like contribution tracking and things like this, and also funding to like pay contributors, hopefully we can start to accelerate our progress. And I think we've been like, it's been progressing really well so far, but if we can improve the processes even more, then yeah, that's also great. Cool. Shall we call it a day for now then? Perfect. Yeah, very interesting. Good to catch up. And yeah, I'll see you next week. And I'll keep you updated in the channel with information and stuff.
Awesome.
Awesome. Thanks, guys.
Thanks everyone.
Thanks everyone. Bye-bye.
Bye.
Bye.
Thank you.